Clean water is one of our most precious resources. There's a finite amount of fresh water on Earth, and we couldn't live without it. A lot of the water we use ends up in wastewater treatment plants. When it gets there, the plant removes contaminants and cleans the water. That way the water can be safely returned to the environment. An innovative SKF solution will help water treatment plants produce clean water with less energy and less impact on the environment. Now let's go see where all this stuff happens. So Mark, what does SKF technology have to do with the treatment of water? I'm assuming it has something to do with bearings.
Actually, Jeff, we use magnetic bearing technology for the wastewater industry.
Magnetic bearings, what is a magnetic bearing?
Well, with a traditional bearing, Jeff, and you can see here an example of a self-aligning ball bearing. You have an inner ring and an outer ring and a set of balls or rolling elements. Now, all of these elements on a traditional bearing make contact with each other and roll and help reduce friction. They need some lubrication to work effectively over a long time. With a magnetic bearing, we eliminate that contact. So instead of having rolling elements touch steel rings, like you would in this type of a bearing, the shaft levitates on a magnetic field.
It levitates, so it actually floats in midair?
Yes, yeah, essentially.
Really? How does that work?
Let me show you, Jeff. We have an app here that explains the principle behind a magnetic bearing.
You have a magnetic bearing app?
Yes, we do, yes. But what you see here, there are a few key components when you look at a magnetic bearing system. One is the magnetic bearing itself. It's an active magnetic bearing, an electromagnet, and that acts as the muscle within the system.
Okay.
So it helps keep the shaft in the position that you want. There's also a sensor that acts like the eyes. So it's going to report to the system if there's any movement and if the muscles should react, if that magnet should provide more power. The sensor sends that signal to the magnetic bearing controller, and that's what does the thinking. That's the brains of the system. And so it takes that signal from the sensor and it decides how much power it should send to each of the magnets in the system.
So if the center part starts to move down, something tells the upper magnet to be more powerful and to pull it back up?
Yep, exactly. So it's illustrated here. If we move that shaft down, you see the bottom sensor lights up, and the magnetic bearing controller sends more power to those upper bearings. You see how they're glowing. And when you let go, it's going to bring it right back to center.
So as it spins, that keeps the wobble out of it. That keeps it so it's spinning true and straight.
That's exactly right. It repeats that cycle. The sensor sends a signal every 15,000 times every second to the magnetic bearing controller. So there's an incredible amount of information that you can get from the magnetic bearing system.
Okay, so Mark, back to my original question, what does SKF technology have to do with the treatment of water?
Well, Jeff, we're in the perfect place to find out. We're here at the Spencer Turbine Company, and they're using the SKF high-speed permanent magnet motor technology with active magnetic bearings for their high-speed turbo blowers.
Can we go see?
Yeah, let's go see. Jeff, I'd like to introduce you to Mike.
Hey, how are you?
Hi, Jeff. Good to meet you.
Nice to meet you.
I'll catch up with you later.
Thank you, appreciate it. So, Mark's been talking to me about SKF's magnetic bearings, but what does that have to do with wastewater treatment?
Well, what we're making is what they call an aeration blower. You've got a series of fans that produces a massive volume of air into the basin at a wastewater treatment plant. So where all the sewerage and effluent is going in, there's actual bacteria in those basins that are really breaking down the organic waste in that stream. And they need oxygen to do that. So our blower delivers that oxygen so that that waste can be broken down.
So what makes one aerator better than the next one?
Well, I thought this would be a great place to start because this is very traditional in the terms of technology. And I think it's important to get a sense of the size of this unit. This unit operates at 3,600 RPM. It happens to use conventional SKF ball bearings, and it's technology that's been very reliable and been around for decades. When you go into the magnetic bearing high-speed motor from SKF, you're now operating at much higher speeds. And why don't we go over and take a look at that so you can get a sense of that.
So you got a new one here as well?
Yes, we do.
Let's go see that.
All right.
That's cool. I like new stuff.
All right, me too. So now you've seen the old technology. Now let's look at what we're getting, as a result of our partnership with SKF.
So what are the advantages? What does it make it easier for you to do?
The old technology we looked at was 3,600 RPM. This technology is 35,000 RPM.
35,000
35,000
RPMs? So the advantage is you're pumping more air.
You're pumping the same amount of air with a lot less energy consumption.
Okay.
So that's the big change.
Okay.
And part of the change is now that you've got those kind of speeds, one of these replaces all those stages you saw in the old unit. This is the impeller. So air is coming into this. This is rotating at 36,000 RPM.
Okay.
And pushing out that airflow at the appropriate volumes and pressures that we need.
So you're able, in this unit, to have just one of
Correct.
these.
The big differences are this takes a lot less maintenance. The only maintenance for this really is changing filters.
Okay.
There's no lubrication. There's no bearings to change. So let's take a look inside.
Yeah, let's do it.
Basically, from this surface to here, the back of this is what SKF provides us along with the magnetic bearing controller. Basically, the whole rotating assembly is operating, in a levitated state, so there's no physical contact, which means we don't have lubrication, we don't have any repair work like we talked about, and it's basically vibration free. The other piece that we like about the SKF package is that the bearings are actively being managed, so that if you get a little bit of a change in things, the bearings are constantly sensing that and repositioning itself. So it's got built-in vibration management.
It's really neat. I appreciate you showing it to me.
Thank you, Jeff.
Thank you. I'm here at the Danbury, Connecticut wastewater treatment plant operated by Veolia Water. I understand this plant has installed a high-speed turbo blower equipped with an SKF permanent magnet motor. Let's go check it out. So Mark, we're here at the processing plant, and as the citizens, we don't really think about all this, but this is necessary stuff. Do you mind explaining to me how it works from when it comes in and when it leaves?
Sure. Our sewage comes in from the plant that's called influent, and what happens is it goes to the primary clarifiers first, these big circular tanks that you see here, and then it goes down to the farther station down there are the trickling filters.
Okay.
And from there, it'll go into the aeration basins, and then finally from there out into the river way in the back.
So, starts here, ends up there.
Correct.
I'm assuming it just gets cleaner all the way down the process?
Correct, exactly. Okay. Each particular tank will take out a certain amount. For instance, the primaries here, the first stop will take out about 30% of the waste.
Okay. And so it just keeps taking waste out along the way, and ultimately it's clean enough to put back into the environment.
Correct.
Okay. I've heard a lot about these aeration blowers. Mm-hmm. Where in the process does that happen?
At the very tail end of the plant, what you have are aeration basins, where microorganisms are there, which are in the influent, and to keep them alive, again, because they are just like a biomass, think of a fish tank, okay? Yeah. They need air, okay? And that's where the aeration blowers come in. They actually put air into the tank to keep the biomass alive.
Okay. So from the company that was building the unit, I heard the advantages from their standpoint, but you're actually the end user. You're the guy that actually is using the unit. So I'd like to really understand how the SKF magnetic bearing technology, how that actually impacts the end user.
To do an apples-to-apples comparison, a conventional blower would consume about 3,200 kilowatts per day to produce the amount of air that we need, again, to keep the biomass alive. Okay. With the particular blower we have right now, we're down to about 1,800 kilowatts.
Oh, wow.
So, and that equates to about a $200 a day savings for us. So if you multiply it out during a year, it is a very substantial savings to us.
That's wonderful. So you're lowering energy costs and you're reducing emissions.
Yes, it's not just the dollars that we end up saving, but by going to a more efficient unit, if you use about 1.8 pounds of CO2 generated per kilowatt hour, we actually mitigate about 400 tons of CO2 into the atmosphere every year.
Reducing energy use and CO2 emissions sounds good to me. SKF's magnetic systems are a sustainable solution for a wide range of industries and applications, and they're part of the SKF Beyond Zero portfolio. I'm Jeff Burton. Thanks for joining us on the journey and for making smart choices in your life to help safeguard the environment.